Welcome to the lecture series on fundamentals of statistics. In this series, we aim to understand the basics of statistics and study various distributions and their applications. In the previous video, we discussed about averages as one of the characteristics of quantitative data. In this video, we are going to discuss about other characteristics of quantitative data. Those are dispersion, skewness, and kurtosis. We will first look on the measure of variation or deviation of the data from the central value, that is dispersion. The literal meaning of dispersion is scatteredness. To understand this, let us consider the following example. There are 3 data sets given. In all these cases, there are 5 observations and the mean is 8. Since the average is same for all, we cannot differentiate in the 3 data sets. But looking at them, we can at least say that data 1 is the least dispersed and data 2 and data 3 are more dispersed from the mean value 8. Here are few measures of dispersion, namely range, mean deviation, standard deviation. Range, as the name suggests, is simply the difference between the 2 extreme observations of a variable of the distribution. It is the simplest and most crude measure of dispersion, since it takes into account the 2 extreme observations which themselves are subjected to fluctuations. It is not at all a reliable measure for dispersion. Note the range calculated for the 3 data sets considered previously. So for data 1, the range is 4, the data 2, the range is 8, and the data 3, the range is 12. So we see that for more dispersed data, the value of range increases, as data 1 is least dispersed and data 3 is the most dispersed. About the central value, 8. Now we will understand what is mean deviation. Let us consider xi be the frequency distribution. Then the mean deviation from average A, which is usually taken as mean, median, or mode, is given by the following formula, where capital N is the total number of observations. Since the mean deviation is based on all the observations, it is better measure of dispersion than range. But in this also, as we ignore the sign of deviation, here it creates artificiality and renders it useless for further mathematical treatment. The standard deviation or root mean square deviation is the positive square root of the arithmetic mean of the squares of the deviation of given value from their arithmetic mean. For frequency distribution xi, the standard deviation is given by the following formula. Since in calculating standard deviation, we take the square of the deviations, hence it overcomes the drawback of ignoring the sign in mean deviation. Also, standard deviation is least affected by the fluctuations of sampling, hence it is the most accurate, appropriate measure of dispersion. The square of standard deviation is known as variance, which is calculated by the given formula, where n is the total number of observations, and it is the measure of how far the set of observations is from the average value. Next is skewness, and the meaning of skewness is lack of symmetry. So we say that given data is skewed if it is not symmetrical and it is stretched to one of the side, and it occurs when mean, median and mode are not equal to each other. In the shown figure, there are 3 graphs shown. So the middle one shows the symmetrical distribution which is not skewed, and here we see that mean, median and mode for the given data are equal to each other. The graph shown to its left is known as positively skewed, where mode is greater than median and the mean is less than median. And the other graph on the right is negatively skewed, where the mode is greater than median and the mean is less than median. The next characteristics of quantitative data is kurtosis. So there can be a set of data which is symmetric about the same mean and have same range. So in that case, how we will differentiate among such data? So here comes the kurtosis in the picture. So kurtosis enables us to have idea about the flatness or pickedness of the frequency curve. So even if the data which we are having, like two sets of data which is having same mean and same range, we can still differentiate between the data with the help of kurtosis. Let's look at the given figure to understand it more clearly. So here the mean of the given data set is same, and what differs is the property of kurtosis. So mesokurtic is the normal curve that is neither flagged nor peaked, and leptokurtic is more peaked than the normal curve, and platykurtic is more flattened than the normal curve. Hence we can differentiate in the given data sets. So that's all for the characteristics of quantitative data. Thank you.